At the end of the last video, I was talking about the example where you rent 5 movies at the video store, remember those? But you only have time to watch 3 of them. And we asked how many different ways could you choose which 3 of those 5 movies to watch. And assuming the order counts, like if you watch the same 3 movies but in a different order, that counts as a different way of doing it, the number of possibilities is 60. And that's an example of the sort of situation where you have n objects to choose from, like 5 movies to choose from, and you're choosing R out of those n objects, like 3 out of the 5 movies, and the order in which they are chosen does matter. So if you watch the same 3 movies but in a different order, that would count as a different choice. That's permutations. That's written in PR. So the big P in the middle stands for permutations. And then you have these subscript numbers on either side of the P. The number that comes first is how many choices you have to choose from. That's usually the bigger number. And the second number after the P is how many of those you're actually selecting. So the situation we were talking about here would have been 5P3. The number of ways to pick 3 out of 5 movies. 5 to choose from, and you're picking 3 of those 5. So to actually calculate that, the rule for calculating the number of permutations, that is, the number of ways to choose R number of objects from among n number of choices, where the order matters, it matters which one is which, is denoted in PR. And I have seen other books that write it slightly differently with the P first and then both of the numbers after the P inside parentheses. But I'll follow the notation of our book that seems to be the most common, which is in PR like this with the subscripts before and after the P. To actually calculate what that comes out to, there's several different ways you can do it. One way is by multiplying together R numbers starting with n. Like when we did 5P3, we multiplied together 3 numbers starting with 5. 5 times 4 times 3. Another way is by using the built-in function or button on your calculator, if it has that, and I'll show you how to do that in just a minute here. Or a third choice is that there is a formula that you can just plug in the numbers for n and r, and the formula will tell you the number of permutations. So that formula is that NPR equals n factorial divided by n minus r factorial. So let's look at an example. To calculate 5P3 using that formula, so here the n is 5 and the r is 3. So the formula says that that would be equal to n factorial, that is 5 factorial on top, over n minus r factorial, that would be 5 minus 3 factorial on the bottom. Now 5 minus 3 would be 2. So on top we have 5 factorial, 5 times 4 times 3 times 2 times 1. On the bottom we have 2 factorial, that's 2 times 1. And that comes out to be 120 divided by 2, which is 60. Now once we get to 5 times 4 times 3 times 2 times 1 over 2 times 1, we could simplify that fraction by canceling out the common factors that appear both in the numerator and in the denominator. So after we cancel out the 2 and the 1, all that we have left are those first 3 numbers, the 5 and the 4 and the 3. So that's why that formula gives us the same result as if we just multiplied together those 3 numbers. Another example, what about 17P4? Well, the formula would say that that was 17 factorial on top over 17 minus 4 factorial on the bottom. Now 17 minus 4 is 13, so you would take 17 factorial, whatever number that comes out to be, divide it by 13 factorial, and that would be your answer. The other way to calculate that would be multiply together the four numbers that start with 17 and then go down by 1 each time. So 17 times 16 times 15 times 14. If you multiply that out, you get 57,120. So that represents the number of ways of choosing 4 things out of 17. You have 17 to choose from, so there's 7 possibilities for what the first thing is, and then 16 possibilities for what the second choice is, times 15 possibilities for the third, times 14 possibilities for the fourth. On my calculator, I could push Math and go back to that PRB menu. And on some calculators, there's actually a button on the calculator that says PRB that gives you a little list of possibilities. Now, before we go here, I need to put in the first number. If I'm calculating 17P4, I'm going to punch in 17, then go to that PRB menu and select NPR, which is the second choice on the list. And now punch in the number 4. So I'm asking my calculator for 17 NPR 4. And it does tell me that that is 57,120. Same as if we just multiplied together 17 times 16 times 15 times 14. Those 4 numbers starting with 17. So, some more examples of this kind of situation. How many ways could a president, vice president, secretary, and treasurer be chosen from a group of 25 people? If you think you know, pause the video and calculate it for yourself before I give you my number. First of all, does the order matter? Does it matter which is which? Well, yes, it does. If we pick the same 4 people, but switched around who got to hold which office, who was president, who was vice president, and so on, that would count as a different choice. So it does matter which is which. Not just which 4 people we pick, but which one of them is which office. So we are doing permutations. This is an NPR kind of situation. How many do we have to choose from? Well, right there it says, from a group of 25 people. So that first bigger number, the N that comes before the P, that's 25. And then how many out of those 25 are we actually choosing? Well, we're picking 4 people. 1 to be president, 1 to be vice president, 1 to be secretary, and 1 to be treasurer. So that'll be the second number, the R. So we need to calculate 25P4. So we can either do that by multiplying together 4 numbers starting with 25. So 25 times 24 times 23 times 22. Or we can do 25 factorial on top over, let's see, 25 minus 4 is 21 factorial on the bottom. Or we can just use that special built-in function or button on our calculator. But however we calculate it, it comes out to 303,600. So that's the answer to this question. How many ways could a first, second, and third place winner be chosen from among 10 contestants? Does the order matter? Yes, it does. It doesn't matter who's first place, who's second place, and who's third place. How many do we have to choose from? 10. How many of those are we choosing? 3. So what we need is 10P3, which would be 720. You can multiply together 3 numbers starting with 10. 10 times 9 times 8, or do it one of the other ways we talked about. How many ways could a network executive schedule 4 shows from among 11 possibilities? Like maybe they've got 11 possible half-hour sitcoms, and they need to schedule one for 7 o'clock, one for 7:30, one for 8 o'clock, and one for 8:30. Does the order matter? Well, yeah, because it matters which one's at 7 o'clock, which one's at 7:30, and so on. How many do we have to choose from? 11. How many are we actually choosing out of those 11? 4. So this would be 11P4. 11 times 10 times 9 times 8, which comes out to 7,920 ways of setting up that schedule. Now, remember our example about choosing 3 movies out of 5 to watch. Now, what if you don't care about the order? All you care about is which 3 movies you end up watching, and it doesn't matter which one you watch first or second or third. Remember, there were 60 ways if the order does matter. But in that list of 60 possibilities, a lot of them were kind of repeats if the order doesn't matter. Like if you watch movie A and then B and then C, that's the same 3 movies as if you watched A and then C and then B, or BAC, or BCA, or CAB, or CBA. In fact, every way of choosing 3 movies appears on this list 6 different times. Once for each of the different orders that those 3 movies could be in. Remember, 3 factorial is 6, and that gives you the number of different orders that those 3 could be in. So if we want to take these 60 permutations and divide by how many different arrangements there are for each individual set of 3 movies, we'll get the number of possibilities where the order doesn't matter, where each set of 3 movies only gets counted once instead of 6 different times. So now the number of possibilities where order doesn't matter is 60 divided by 6, which is 10. Down at the bottom here, you can see what those 10 possibilities are. There's the 10 ways of picking 3 out of those 5 movies if the order that you watch them in doesn't matter. You could watch movies A, B, and C, A, B, and D, ABE, ACD, ACE, ADE, BCD, BCE, BDE, or CDE. Any other possibility would just be a different ordering or rearrangement of one of those 10. So when the order does not matter, you have a certain number of objects to choose from, you're choosing some of those objects, and you want to know how many ways there are of making that choice. If the order in which they are chosen does not matter, we call that combinations. So permutations is where the order does count. Combinations is where the order does not count. And I'm going to end this video here and come back and talk more about combinations and how you calculate those in the next video.